Saluda Grade, Saluda Grade.
I'm co-editor of the Southern Railway Historical Association magazine, which is called Ties Magazine. This was the fourth quarter 2015 issue that featured an article that I wrote because I happened to be out here taking pictures of the last run of the Carolina Special up Saluda Grade on, December 5th, 1968, something like that. And the magazine was so popular, we pretty much sold out of it. So what the association has done is that we've made available a high-quality DVD of the magazine in its entirety, which is on here. This too is for sale here at the Depot gift shop. I wanted to mention how pleased I am to be back again. Thank you for your warm Saluda welcome. I enjoyed being here last December, and I'm going to run through a fair amount of history and discussion of locomotives. I hope I don't get too technical for you, but I think it's important to understand or to appreciate what kinds of locomotives ran through here 60, 70 years ago. This must have been a pretty noisy, smoky place at one time. Everybody who's sitting in this room probably knows where Saluda Grade at least ended. You can see it from here. This is a little map to kind of give you an idea of what's what. The yellow part of this map is where the grade actually is. It's from Melrose to Saluda. And if you start up at the top, the depot is approximately where that dot is with the word Saluda, just east of the 32 milepost. These ovals indicate where the mileposts are between Tryon and Saluda. So what's the big deal about Saluda Grade? What is it that's so special about Saluda Grade? Well, as you probably heard, it was the arguably the steepest mainline railroad grade in the United States when it was in operation. The average grade was somewhere around 4.7%. That's the number that is usually mentioned when you mention how steep Saluda Grade is. I want to make a comparison here. This was a main line. This was a Southern Railway main line out here. In its day would have maybe as many as 10 or 15 trains a day. That's not including the helper moves that would, after they'd help a train up the mountain, would back down to Melrose for another push or another pull. From an engineering standpoint, the most impressive railroad I've ever seen in North America is the Canadian National Main Line. Canadian National Main Line, you can still ride over it today on the Via Rails Canadian, the Vancouver to Toronto train, and my wife and I do that every year. But it is such an efficient railroad that between Winnipeg, which is in the prairies, between Winnipeg and Vancouver, which is on the west coast, the ruling grade, the maximum grade against any freight train going westbound is 1/2 of 1%. Eastbound, it's almost as good at 0.7%. And here's the territory it's going through. This train is going to have to get through these mountains somehow. And they do it with good engineering and good rivers in the right places and tunnels in strategic places and things like that. The old Spartanburg and Asheville, when it built up Saluda Grade, didn't have quite that luxury in 1877. But Spartanburg and Asheville, when it built up, when it was ready to build up into Saluda, had two choices. It could either build by way of Columbus, which I see an exit on I-26 for. Never been to Columbus, but they could have put a railroad there. It would have involved 13 miles of circuity, so I understand. That's about the same amount of zigzagging and circuity that you have between Old Fort and Ridgecrest, if you're familiar with that stretch of railroad. Several tunnels would have been necessary, and I think the singular reason why they didn't choose that route is because of unstable soil. I've seen stories before about how a railroad will enthusiastically try to go from point A to point B, and they dig a tunnel and it's all sand. And as soon as they go forward 10 feet, it just caves in and they just keep doing more and more and more. And I think that may have spooked them, the unstable soil and the slopes. The alternative to that was to build it straight up Saluda, nice, short, compact distance of 3 miles, and the trade-off is 4.7% grade. And it took them a long time to get up here, as I remember my history correctly. Well, service began down the grade in 1878. The wrecks were taking place before they got to Asheville. Shortly after, I think, the Spartanburg-Asheville went belly up and became the Asheville and Spartanburg. It was bought by the Richmond and Danville. And the Richmond and Danville really didn't want to build it into Asheville. It was in no hurry to. This is before air brakes were universal. This is when, to stop a train, the locomotive engineer would give a certain whistle signal to the 2 or 3 men that are running back and forth on the top of the train, that in order to slow it down or stop it, they're turning handbrakes in order to slow the train down. It was a pretty inefficient way to stop the train, and so when the air brakes came along in the 1880s and 1890s, some railroads adopted them more enthusiastically than others, but that was the real difference in, air brake made the real difference in the runaways that would occur on Saluda. This is in Saluda, by the way, 1883. It's just a 4-drivered passenger locomotive with really high wheels. Trying to go up this grade with something like that. No wonder there were 2 engines with 4 cars behind them. You know. Southern Railway was formed in 1894, and its principal component, one of its 2 principal components, was the old Richmond and Danville. And once the Southern Railway became a system, and they started looking at the different areas that they served, they started to see strategic value in this line here. Southern Railway put the pieces together and realized that this could be on the middle of a main route between the Port of Charleston and the Midwest, the Ohio River. And that was a principal reason for this railroad to exist all those years, was it was a conduit between the Port of Charleston and the Asheville, Knoxville area in the Midwest. But the wrecks didn't stop. In fact, in 1903, there were 3 wrecks in 1 year. And an engineer in the first wreck, who spent a better part of the year thereafter in a hospital, had a lot of time to think about what he could do to make the route safer down Saluda Grade. And he came up with the idea of the safety tracks. They didn't have safety tracks before then, but 1903 was the year when the air brakes were pretty much in general use, although they did have the hand brakes being used also. 1903 was the year that the first K-class engine arrived. They had 8 driving wheels. They had no wheels under the firebox. They had 2 wheels up front. They were a 280 wheel arrangement, as they say. This is a 282. It is a locomotive type that was developed after the K-class. All of the locomotives on this list operated right out here, except for the MS4s. This is a standard MS class 282 right here. What they did is they took these to Spencer Shop or the Baldwin Locomotive Works or somewhere like that. They found a 280 type locomotive that was obsolete, may have been built in the late 1800s or something like that, and the boiler had worn out. They didn't want to rebuild it, but the running gear was in pretty good shape, so what they did is they stuck it underneath the tender. And when the locomotive needed a lot of power, the engineer would throw another throttle lever in the cab and shoot some of the steam from the boiler back into the chassis right here to help with additional power going down the road. These were called tractor engines, and the whole ensemble is called a duplex. Well, Southern built 7 of these things between 1915 and 1917. They were all assigned up here to Saluda Grade rather. And as I understand it, the way the operation went is this: they would leave Spartanburg with a train. They'd get 1 or 2 helpers up the grade and then continue on, and they would use the tractor engine when it was needed the most. Now, it was sometime in the 20s that they started, that the 210-2s and some of the 288-2s migrated to this part of the world, started working up Saluda Grade. This was in the 20s. This is the roaring 20s when railroad business was really great. They put a bunch of these things in mothballs. And when the Depression came along, they put a lot more of them in mothballs, and they just sat there until the late 30s. So how did a train get down the hill? There was a process in 1948 for doing it when they were using all steam power out here. And there was one stop board, and the train would pull up to it with a freighter passenger train. The brakes would be inspected, and the crew would turn up the retainers, which is a feature on the air brake system that once you apply the brakes once, retainers will allow the brake shoes to kind of hug the wheels, but not press tightly on them. But the idea is that when you're going down a hill, you want those retainers to have contact with the wheels so that any variation in air pressure that would activate the brakes would make them grab right away. If they were in their normal position to where they were several inches away from the wheel, it might not be as effective as when the retainers were deployed. Also, you charge the train line to 100 pounds. The standard was about 80 pounds. So you'd have an extra 20 pounds of pressure going down the grade. Once all that was taken care of, trains would sit out here for quite a while, turning up the retainers. And the longer the trains got after dieselization, the longer they sat out here while they were turning up retainers. But anyway, after starting over the lip of the grade, the engineer would apply and release the brakes to activate the retainers. And then apply the brakes as needed to keep the speed under 10 miles an hour. You still, at that time, had 5 or 6 man train crews, and you had a couple of your train crew members on top of the freight cars to keep an eye out for hand signals from the switch tenders. There were 2 switch tenders between here and Melrose that guarded the safety tracks. The engineer would blow a certain whistle signal that his train was under control or that he was approaching the safety track. The switch tender would give a hand signal saying, understand you're under control, the track is lying for you to go down the grade, or I also understand that you're not under control and I'm not throwing the switch, you're going up the safety track. So that's how they communicated. This is before the days of radio. And at Melrose, once they got down to the bottom of the hill, they'd stop again, they'd turn down the retainers and would inspect the train to make sure all the brake rigging was still intact and working properly. The process for going up the grade was a lot simpler. The train would arrive at Melrose and the helpers would couple on the front, or maybe the front and the rear. They would make a brake test before they left to make sure that all the brakes were working on all the locomotives in the cars. No radio, but the lead locomotive would give the right whistle signal. The other locomotives would hear it, so they'd all take off at the same time. And since they didn't have to worry about setting brakes or anything, because they were just going to go charging up the grade, they would leave Melrose in a cloud of dust. And when they got a half a mile from safety track number 1, about in the middle of the grade, engineer would give one long whistle saying, hey, I'm coming up the grade, why don't you throw that switch for me, that safety track switch, so I can keep going up the main line. And when they got to the top of the grade, the helpers came off here in Saluda. One locomotive and the train would continue on to Asheville, and the helpers would go back down the hill again for another push, another shove. So in 1949, the diesels arrived, and boy, a quantum jump in productivity is the way I would put it. First of all, they had more braking power than a steam locomotive did, because they had not only air brakes, they had dynamic brakes. Dynamic brakes are, well, diesel locomotive has a big 16-cylinder diesel engine in there that generates nominally 1,500 horsepower, let's say, in 1949. But that's not what drove the locomotive. What it did is it drove a generator, which generated electricity. Electricity went to electric motors on each of the 4 axles. So we call them a diesel locomotive, they're really diesel-electric locomotives. And they had the perseverance and the stamina of an electric engine. It was fine for going up the hill. If you're going down the hill, you could change the electronics in the electrical cabinet and turn them from motors to generators, so that they would be generating resistance as you were going down the hill. It was another form of braking. It was called dynamic braking. So the diesels came with dynamic braking to go down the hill. You had improved air brake controls, and again, going up the hill, you had the smooth electric traction that I mentioned. Fewer helper engines were needed. One 4-unit F7 locomotive in 1949 was rated at 6,000 horsepower. It was rated at 1,500 tons up the mountain. One of the 2 10-2 Santa Fe's was rated at 500 tons up the mountain. So 3 of the mighty Santa Fe's equaled just one of the F7 4-unit sets. Here's a 4-unit diesel going up the grade. Another 4-unit diesel going up the grade when it was brand new. This thing's got a steam helper. You can see this cloud of smoke right back there at the very top of the picture. Carolina Special stopped at the depot at Saluda in 1968. That's what it looked like in 1954. That was just a tidy little picture, neat little depot. It's gray with white trim in this photograph. Nice asphalted platform. This is a neat little depot. I'm so glad you guys have restored it. It's in really good shape and getting a lot of use.
Now the locals tell of stories of those faithful engineers who'd ride on to the end and die in vain.
Well, thank you all very much.